Let f of x be the absolute value of x minus 1. The graph of y is g of x is drawn below. Find the value of f of g of 1. So it's a composite function, f of g of 1, and it becomes f of g of 1 it's 0, so we need f of 0, and substituting 0 for x into f, we get 0 minus 1, so it's negative 1. Find the value of f of g of 1. So it looks like f of g of 1, and it becomes g of 1 is 0, so it's f of g of 0. G of 0 is 4, so it's f of 4, and substituting 4 for x into f, so we get 4 minus 1 is 3. The next, sketch the graph of y is f of g of x. So it becomes, we substitute g of x for x into f, so it becomes the absolute value of g of x minus 1, and some function and the absolute value. We need a part of the graph corresponding to negative values of y. It should be reflected about x-axis, so graph of g of x, the absolute value, it looks like this, and also this part, it's the same. Positive part for y values is the same, and a negative 1, it's a vertical translation, 1 unit downwards, hence the required graph looks like this. These points were just g of x is 0, it will be negative y on y-axis, so it looks like this, and it will be here, 3 here, negative 1, and it's negative 1, negative 2, and something like this, 1, 2. Okay, the next, sketch the graph of y is f of x. F of x is just, we need to draw a graph, the absolute value of x, it looks like this, and negative 1 at the end, it's just translated 1 unit downwards, so it looks like this. It's negative 1, 1, negative 1, y, x. The next, state the zeros of f, and zeros of f are negative 1 and 1. Then sketch the graph y is f of x, so it's the absolute value of the absolute, we can write given function f, the absolute value, and negative 1. So sketch states the zeros, so you can deduce that to plot, if it's needed, to plot a graph f of f, we substitute f for x into f again, it looks like the absolute value of f, and it's again the absolute value of a drawn graph function. So we need reflect about x-axis a part of graph corresponding to negative values of y, so it becomes like this. It's just f of x and the absolute value, and -1 just 1 unit downwards, and it becomes 1, -1, 1, and 1 unit downwards. It becomes this point becomes at the origin, and 1 becomes -1, and it looks like this. And since for the absolute value of x, its graph is going at 45 degrees, or it's a bisector of a quadrant, so you can deduce that since it's 1, x-intercept is at 2, and -1, -2. So zeros of f of f are 0 and ±2. The next, and sketch the graph. So this graph is here. It's graph of f of x, which is the absolute value of f minus 1, and 0, 0, and ±2. Given that we can denote f of f and so on as fn, find the zeros of f3. And if we consider f3, it's again it will be f of this f of f, and again it will be the absolute value of f of f, and then -1. So again we need just reflect about x-axis, the negative part of the graph, to get the absolute value of f of f, and then 1 unit downward. So it becomes like this firstly. So f3 is f of f of f, and we need to plot the absolute value of f of f -1, and it's f of f, the absolute value, and points are -1 here, -2, 0, 1, 2, and then 1 unit downwards, it becomes -1 here. At 1 will be 0, 1, 0, at 2 -1, and at 3 again 0, and -1, -2, -3, and it's f of f absolute value -1, which is the graph of f3, and we can see that roots are +-1, +-3, +-1, and plus minus 3. Find the zeros of F4, and F4 it will be again reflected about x-axis and 1 unit downwards. So reflected it becomes -1, 1, 1, then 2, 1, 3, -2, 1, -3, and 1 unit downward. So it becomes 0 at -1, 1, y is -1. At 2 we get again 0, 2, -2, and at 3 it will be -1, and also at -3 it will be -1, and -4 and 4 are also x-intercepts, hence it's F4. And we can see roots are 0, plus minus 2, plus minus 4. 0, plus minus 2, plus minus 4. And we can notice that F2 0 plus minus 2, F4 0 plus minus 2 plus minus 4 deduces 0, so we can guess that it will be 0 plus minus 2 plus minus 4 plus minus 6 plus minus 8. The zeros of F2n are A1 and A2 and so on up to AN. State the relation between n and n. And for example, let's consider this, or F4, it doesn't matter, and we can see that since for each there is plus minus, we can see that for F8 there are 2, 4, 6, 8 plus 1, 9 zeros. For F4, 2 plus 2 plus 1, 5 zeros. 5 zeros, 9 zeros, so we can deduce that there are one more zeros than this value, and since it is denoted as 2n, hence n is 2n plus 1. Find and simplify an expression for the sum and the absolute values of all roots in general in terms of n. And again, if we consider an example for F8, we need consider 0 plus since there are two roots plus minus 2, it will be plus the absolute value of 2 plus the absolute value of -2, which is also 2, plus the absolute value of -4, which is 4, plus 4, and so on. And hence we can write the next, that this sum is equal to this sum from 1 to 2n plus 1, because capital N is 2n plus 1, and it will be the next 0 plus 2 times 2 plus 2 times 4 plus 2 times 6 plus 2 times 8 plus and so on. And we can see the relation since 8, 8, so the last one will be 2 n, and also since plus minus it will be 2 multiplied by, and we can factor out 2 and actually don't take into account 0, so this sum becomes 2. Let's factor out, and the first term it will be 2, and the last term it will be 2n, and using formula from a data booklet, the sum of the first n terms of the arithmetic sequence, it's the first term plus the last, so it's 2 plus 2n divided by 2 and multiplied by the number of items. And now we can see that it's the first term, the second, the third, and it actually looks like 1 times 2, 2 times 2, 3, so we can see that there are n terms. Or actually it's clear from here, then if we consider 8 as 2n, n is 4, and if we don't take into account 0, we can see that there are 4 terms here. Hence there are n terms in total, and we can see that it is equal to 2n plus 1. And that's all for this question.